For mapping today, we're learning about prisms and finding surface area and volume of prisms. So when I talk about a prism, this is a prism, right? The idea that I have something with a certain shape on its base, in this case it's a circle, and that it has some 3D-ness to it, right? That it's had like repeated circles if you think about it going that way. This one's a cube, so it has a square, and it has repeated things. I could take any shapes, think of a tent with a triangle, and you'll see me do various ones here. So let's start with the idea of volume of any prism. The way my brain thinks about it is in general, if I get stuck, I don't memorize formulas. I think about the area of a base, whatever shape that is, whether it's a circle, triangle, rectangle, anything like that, times. Now, the height isn't the right word in a way. The height is really the distance from base to base. So if I was talking about this, when I mean height, I don't mean like the radius or the diameter of the circle. I'm talking about the distance from this circle to the other one. So let's look at a few different shapes just to talk about them. So let's start with a rectangular prism, meaning the bases are rectangles. So if I think about this picture, it is going to be something where I have a rectangle, forgive my artwork, and it's gonna look like this, where I kind of have a length, a width, and this height going back. So if I take the area of the base, right, if I'm trying to find the volume, it would be the area of the base, which is length times width, times this height. Simple enough, right? Let's think about a triangular prism. So again, now I have like a tent. So I want you to think like tents. Again, forgive that my artwork is not the best thing ever. So you can imagine there's another triangle shape over here in the back. So when I think of a triangular prism, I need to make sure I'm finding this height from the perpendicular from whatever I call the base for my triangle. And then I want you to think about this as this is like a different height. So this is the height of the triangle. This is the height of my prism, like if I stood it up on its triangle end. And that's where it gets confusing, that if I almost call it height 1 and height 2, that people get confused what I'm talking about. So again, that's why I say if you think about what's the area of the bottom shape. The area of the bottom shape is a triangle, which we should all know is the area of the base times the area of the triangle's height divided by 2. And then I'm gonna have to multiply it by the distance between one base to the next. In this case, that would be that secondary height. The last one is a cylinder, which is really just a circle one, right? That's what I showed you here, right? Was a cylinder. So if I think about that shape, again, not the best artist here, but we'll go for it. Here, again, the area of the base, I should know the area of a circle at this point, that the volume of a circle is pi r squared, and when I'm talking about the height, again, the height from the one base to the other, so I multiply times that height. Surface area, you really have to think about all the sides. So think adding all sides. So let's go back to our rectangular or prism. So if I look for the surface area, what I kind of think about, I know a cube, all the sides are the same, that's too easy. Let's think about if this was rectangular. Well, I kind of have a matching side on the top and the bottom, the left and the right, this side and this side. So I kind of have sets of matching sides. So I kind of have 2 times the width times the length. Kind of think of all the combinations we can do. Be consistent here. And the last one we haven't done is the length times the height. So if I kind of take 2 of each of those and add it up, I get the surface area. Triangular one, I always suffer to write it out nicely, but I'll try to discuss it. To find its surface area, I first think about the 2 bases. Each base is 1/2 base times height, so 2 times 1/2 that base times that, remember we talked about this being the height of the triangle. So if I multiply that together, that's really 2.5 cancel out, so it's get the base times the height of the triangle. And then I need to figure out each side of the triangle. So if I kind of imagine each side of the triangle might have a different length, and I need to multiply each of those times the height. So I'm gonna put each side rectangle. I cannot give you a better formula because they vary so much, but if you think about it, it's not too bad. Cylinder is a little easier. For a cylinder, again, for surface area, we think about the idea that I have one circle on top and one circle on the bottom. In other words, I have 2 times the area of a circle, 2 pi r squared. And then I take the circumference, because if I unwrapped the sides, like if I took this off and I unwrapped this outer part, the rectangle I would get would be the circumference times the height. So the circumference is 2 pi r times whatever the height of the cylinder is. That's a formula I can use every time. That's a formula. This one's a little more difficult. We'll keep practicing, and if you have any questions, please come and ask me.